Welcome to all from the YouTube channel Step Up Bengal. স্টেপ আপ বেঙ্গলের ইউটিউব চ্যানেল টিম থেকে সকলকে স্বাগত জানানো হয়। আমরা ক্লাসিক্যাল মেকানিক্স we are discussing classical mechanics for math based students preparing for CSIR set etc. So what we have already learned about degree of freedom which is abbreviated as DOF, সংক্ষেপে লেখা হয় DOF, degree of freedom। এর যে মেন কনসেপ্ট আমরা এটা এখন যেটা শিখবো সেটা লেকচার 5। নাও উই আর গোয়িং থ্রু লেকচার 5 of classical mechanics, but all of you are requested to see specially the results of lecture 4 like simple pendulum, just to revise all these concepts. Simple pendulum, what will be the degree of freedom in case of simple pendulum, and then we have also discussed the motion of dumbbell, and for that we have discussed degree of freedom. So all of you are requested to please revise all these concepts from our playlist. If you go to playlist of classical mechanics in our channel, then you will all avail what we have already discussed. This was the last result, in fact, discussed in our last lecture, lecture 4. We finished here. আমরা এখানে শেষ করেছিলাম, আগের দিন আমরা এখানে শেষ করেছিলাম এবং দেখিয়েছিলাম we have shown that 3D space with k constraints, total degree of freedom will be 3n minus k. Now continuing this topic, we will move ahead and just learn one or two very important concepts regarding degree of freedom. It is true that the questions on this particular topic was last probably set in December 2012. After that 2012, after that no questions have been set from here, but it does not guarantee the fact that it will never come back. It may so happen that it may come back. So we should all realize all the aspects of regarding degree of freedom, and just next example after dumbbell we should move up to rigid body. What is rigid body? In a word, এক কথায় বললে a rigid body is aggregate of particles, অনেকগুলি বস্তুকণার সমষ্টি, সেগুলো সব পয়েন্ট লাইক। এক একটা পয়েন্ট লাইক পার্টিকেল যদি এগ্রিগেট নেওয়া হয় টোটাল, অ্যাজ এ টোটাল তারা ফর্ম করবে রিজিড বডি। বাট একটা স্পেসিফিক feature that rigid body must follow a particular feature. Say this is the first position of a rigid body, and after some time this particular rigid body, this is the same body, and it has moved up to here, and say the distance between these two particles in the position 1 was 5 centimeter, then in the position 2 it must be 5 centimeter also, otherwise we cannot call that a rigid body. অর্থাৎ এর ভিতরে যদি দুটো পয়েন্টের মধ্যে দূরত্ব ফিক্স রেখে রেখে চলে, এরপরে এই দূরত্বটা সাপোজ it was 2 centimeter, now in the new position it should be and must be 2 centimeter also, then we call it a rigid body. But when we discuss the degree of freedom for the motion of a rigid body, we just go through a very simple foundation. We have to compose a simple foundation which the students from physics background often create. They just form a simple foundation to realize what should be the degree of freedom in case of rigid body. That means a body where the distance between any two particles will be fixed when it moves from one position to another. So in a previous picture, if the distance, say the distance between these two is 7 centimeter, and now in the new position it becomes 6 centimeter, then we cannot call it as rigid body. That new body will be deformed, বিকৃত হয়ে যাবে। এটা এখানে আলোচনার বিষয়বস্তু নয়। We should not discuss it in our syllabus of CSIR, NET or SET. So simple foundation, what is the simple foundation? That simple foundation is called, in the physics background, three particle system. What is three particle system? Now the point comes, what is three particle system? Say this is one particle, this is two, this is three. That means the vertices of any triangle, this is three particle system, A, B and C. Clear? So the coordinate and all the thing is happening in three-dimensional space, which is in real analysis called R3. Euclidean space, three-dimensional. So what is the coordinate of A? Say x1, y1, z1. Similarly for B, x2, y2, z2. And for C, x3, y3, z3. Now the question comes, in three-dimensional space R3, if three particles are there, we know if they are free, then their degree of freedom will follow 3n formula. 3n formula, where n denotes the number of particles. Here three particles are there, so 3 into 3 equal to 9 free. For free movement, 9 DOF should be there. That means for a three particle system, DOF হওয়া উচিত ছিল 9। কেন? কারণ তিনটে পার্টিকেলই ফ্রি ছিল শুরুতে, এদেরকে কোনো রড দিয়ে আমি যোগ করিনি। ইফ দিস থ্রি পার্টিকেলস ওয়ার নট জয়েন্ড বাই রডস, লাইট অর হেভি, হোয়াট এভার ইট মে বি, then the degree of freedom for those three particles, free particles, this is the point to remember, free particles will be 9. But here we see three constants. This one constant is this rod, the another one is this, and the final is this. এই তিনটে রড থাকার কারণে here 3n minus k formula will give us 3 into 3 minus 3 rods, that means 6. So whenever we have three particle system, this simple foundation tells us that it has degree of freedom as 6. This is an important result we should remember. What is the result? That result is for three particle system, that means that simple foundation I was talking about, for three particle system, DOF should always be 3 into 3 minus 3, that is 6. Here we should request all the students to follow not this direct 6 results. You should just see this breakup once. Just see this once. Because in case in exam hall, if you cannot recall what is this result 6 or 5 or 9 etc., then this foundation, simple foundation, will help all of you to just quickly recover your results, as these three are free. So total 9 minus 3 rods, 3 constants. Whenever we see some rods in rigid dynamics or say in any classical in classical mechanics for any body, we just regard those as constants. So finally, three particle system always enjoys in fact degree of freedom 6. Now comes rigid body. As we are discussing rigid body. Rigid body is hypothetically very similar to three particle system. So the degree of freedom of rigid body in physics is conventionally taken to be three particle system. Clearly its degree of freedom will be 6. So up to now what we are studying, this rigid body. We all know that children play in the park where a small child is enjoying swing. So this total system where that girl or boy is sitting, this is one of the simplest example of rigid body. We should remember it well, because the motion of a swing in any park where the children like to play is very important from physics perspective. We will see later. Now the question from here transferred into another very important concept, just as I was talking, can be described or developed from this particular example. What is the beauty of swing? Just we would see. Say a child just goes and sit in his or her seat, and someone just pushes that swing. What will happen? The swing will in a moment come to its next position here, and the child will be here enjoying the afternoon. Clear? সো এই শিশুটা যে সুন্দর বিকালটা অনুভব করবে, প্রত্যেকে খেয়াল রাখবো, though the swing is changing its position, but this particular rod AB that is fixed. So if we consider the swing as rigid body, as I was talking, rigid body, here the rigid body is making its motion about a fixed axis. This is very important concept for any kind of exam where classical mechanics is in the syllabus. So we call it motion about a fixed axis. মোশন অ্যাবাউট অফ ফিক্সড অ্যাক্সিস বলতে আমরা কি বুঝবো? যখন একটা ফিক্সড অ্যাক্সিসের সাপেক্ষে এই পুরো সিস্টেমটা, যেটা রিজিড বডি ছিল, যেটাকে আরও সহজ ভাষায় ভাবলে আমরা থ্রি পার্টিকেল সিস্টেম বলছিলাম, সেটা যখন সহজেই একটা অক্ষের সাপেক্ষে ঘুরবে। সো এই মোশনটাকে ডিসকাস করা এবং এর ডিওএফ বের করা জন্য আবার আমাদের এই থ্রি পার্টিকেল সিস্টেম দিয়ে কনফিগারেশনটাকে, উই জাস্ট গো থ্রু থ্রি পার্টিকেল সিস্টেম to realize the degree of freedom for the motion of a swing like substance. Another important example that is very important, we often travel in railways, and especially in the months of winter, what we will like to do, just say this is a door, we just shut it so that no air disturbs us in the chilly atmosphere. So when we consider this line as a fixed line, this is our fixed axis, and if after some time we just do not lock the door, for the motion this particular door comes here. So some angular displacement is here. This is called angular, একে বলা হবে angular displacement. Displacements are two types, one along straight line, that is called linear displacement, and another one is along a particular angle, that is called angular displacement. So the motion of a doorway carriage will be another fine example of motion about a fixed axis. These two examples are very much important. We will see later that questions have been set in CSIR from this particular topic. So if we have to just realize what is the beauty of the such system, examples, these two examples, the DOF, how can we conclude about the DOF when the body is making a motion about a fixed axis? That means an axis is already fixed. We all have door in our houses where we see a structure which is fixed and our door just is swinging about this structure. This three-sided structure in our door is always fixed. So that same example comes when we just travel in railways or etc. And if this is the example, children enjoying swimming in park. So if we have to realize the DOF in these two cases, then we have to go to again three particle system, because these two are rigid bodies, and rigid body, as we have already said, conventionally is very similar to three particle system. So we just go to three particle system and realize about motion about a fixed axis. So what was our three particle system? This was three particle system. This figure is extremely important to give us the idea about the degree of freedom of motion about a fixed axis. Suppose we have 3 points A, B, C, three particle system. So it is very similar like rigid body. And for the sake of simplicity, we have taken this fixed axis from here. Since the axis is fixed, this is fixed. And about this fixed axis, it is making motion. That means it is rotating. This figure is rotating. এটা ঘুরছে এই ফিক্সড অ্যাক্সিসের সাপেক্ষে। যখন এটা ঘুরবে খেয়াল রাখো এই ফিক্সড অ্যাক্সিসের উপর সমস্ত পয়েন্ট ফিক্সড, তাহলে এ পয়েন্টটাকেও ফিক্সড হতে হবে। তাহলে এ পয়েন্টের হোয়াট ওয়াজ দ্য কোঅর্ডিনেট অফ a point A? That was x1, y1, z1. Since the axis is fixed, so every point on it is fixed, and so will be A. So this point is fixed. Again, B and C, just consider B and C. Suppose this is the second position when it is moving. This is the second position. After some time, this triangle comes here. This triangle comes here. This is the second position. From first position, this was first position, this was second position. But what will be the beauty? If we just fix a particular axis here and measure z axis upwards, then this B and C will go to B dashed and C dashed, say, but their vertical heights from the base, that means this fixed line, will be the same. So if the coordinates of B and C were initially x2, y2, z2 and x3, y3, z3, when it goes to the second position B dash C dash, say, then that vertical height z2 and z3 will remain the same. This z2, that is, should be constant, and here z3 should be constant. If you just make a structure like this in your house and make it just swing about a fixed axis through A, you will see that from your floors, this is, suppose this is the floor of your house, from the floor the height of these two will remain the same even if it is moving. So how many coordinates are fixed? We are totally enjoying, when the system was free, it was enjoying 3 into 3, that means 9s. From those 9 free segments, we have already eliminated 3. 9 minus 3 because of these 3 fixed rods. So ultimately we have like this for 3 particle system, and now when it is swinging about a fixed axis, again it is getting reduced to further state, as these 3 are fixed, so we should just eliminate these 3, x1, y1 and z1. I am repeating again, as this axis is fixed, so every point on it is fixed, so will be x1, y1, z1, so we have to eliminate this portion. We have already discussed. See, this portion we have already discussed when we have discussed 3 particle system. Here was the result, 3 minus 3 into 3 minus 3, that means 6. So we have already 6 in our hand, and from that we have eliminated these 3 because this point is fixed. And when it is rotating, the vertical heights, that means z2 and z3, will also be eliminated. So here will be 1 elimination number and 1. So ultimately what we will get, 6 minus here 5, so 1. So that is the very important result we have finally arrived. আমরা পেয়ে গেলাম অত্যন্ত গুরুত্বপূর্ণ result. That result is DOF for a body moving about, obviously rigid body, moving about a fixed axis will always be 1. We hope that all of you have understood this configuration. Again, if you have any type of difficulty, please comment, so that we can immediately give the corresponding support. But in exam hall, we always need results. So this is the result. Even if we just forget about degree of freedom structure, that means this particular detailed structure in exam hall, it does not matter much if we can just recall this result 1. That means about fixed axis or door of a railway carriage, they are enjoying just 1 degree of freedom. And for 3 particle system, we have already seen that this is 6, not 5, not 9, this is 6, because 3 into 3 minus 3, that is 6. So for a rigid body, DOF will be 6, and for a rigid body rotating about axis, this 6 is further reduced to 1. So these two are very important results for any kind of exam when we just further proceed to any exam hall. সকলে নিশ্চয়ই বুঝতে পারবে যে এই ধরনের এক্সাম হলে এই ধরনের রেজাল্ট অত্যন্ত ইম্পর্টেন্ট হয়ে যাবে যখন তোমরা পরবর্তী সময়ে এটা পরীক্ষাগুলোতে যাবে। এখন আমরা এই ধরনের প্রবলেমগুলোকে ভালো করে রিয়ালাইজ করব আরও একটু ডিটেলসে। কেন? এখন আমরা পার্টিকুলারলি বুঝতে চাইব একটা ইম্পর্টেন্ট জিনিস, দ্যাট মিন্স কেমিক্যাল বন্ডিং। উই উইল নেক্সট সি chemical bonding in chemistry or chemical science, and the structure of DOF in some special cases in chemical bonding. Now someone of you can just put a question here, that why it is necessary to discuss DOF in chemical bonding also, because we are learning mathematical physics, not the chemistry. But the fact is that CSIR has also asked questions from it. We should see later. First of all, we should see the last important part of degree of freedom, that means in case of chemical bonding, what will be like that. We have seen in 3-dimensional Euclidean space R3, a free particle is always enjoying 3n DOF. In chemical bonding, this 3n actually is supposed to break in 3 parts. First part is degree of freedom due to translation. Second part, degree of freedom due to rotation. Third part, degree of freedom due to vibration. This stands for translation. This R stands for rotation. এই R বলতে আমরা rotation কে বুঝবো, and this V stands for vibration. So whenever we have chemical bonding, the total degree of freedom is actually the composition of these three. We should learn or have to learn part by part about these three very carefully. See, what is translation? For that, we should just see a particular chemical bonding. This one, H2O. As we all know, without it, no animal can live, no plant can live, etc. So this is a necessary thing in our life. H2O, that means water. So first of all, let us draw the three-dimensional system. These three axes, X, Y and Z, and put that water molecule here. This molecule is shifted here. So this is H, this is H, this is O. Now first of all, we should realize translational motion. What is translational motion? See, if this is Z axis and this is the negative Z axis, cannot we just move this system, this three particle system, upward and downward along this particular straight line? That is Z axis. Yes. So any kind of motion along a particular line is called translation. So what is translation? Translation বলতে কি বুঝবো? যে কোনো ধরনের মোশন যেটা সরলরেখা বরাবর ঘটছে, তখন আমি বলবো যে এই পুরো সিস্টেমটা ট্রান্সলেট করছে। সো হতে পারে এই দ্যাট সিস্টেম কামস হিয়ার ফার্স্ট and then it can come here also. So translation is possible along Z axis. Very similarly, it is possible along X axis also, because if we just make it move here in this direction or in this direction, then it is possible also. So one along Z axis, one along X axis, and also along this axis. If we just shift this system, then we have the movement along Y axis also. So how many translational motions is this system enjoying? This is clearly 3 along X axis, along Y axis, along Z axis. Clear? I think all of you have good idea about it. In case of any difficulty, please comment. And now we should just come to this again. See, if we fix the Z axis, then cannot we make this system rotate this particular system? This is our O, this is one H and H. Cannot we be able to rotate this along about Z axis? Rotation is always about and translation is always along. Just you should all remember this. So cannot we all move this or rotate this about this Z axis? Yes. So rotational motion about Z axis here is possible. So it is similarly possible for X axis also, because we can rotate about X axis, about Z axis and about Y axis. So also we have this rotation here as 3. So two types of degree of freedom due to translation and rotation, these are clear to us now. So what will be the vibrational motion? What is the nature? This nature is very much complicated. We just realize it. We should just realize it, but we should calculate it, but using simple formula. Just see here, vibrational degree of freedom. If questions have been set on vibrational DOF, what we will do? We will just eliminate 3n from 3n. This 3 and 3 6, so minus 6. This is the result. We should remember. But on the way, we must take a small look at vibration, mini look you can say, ছোট করে দেখবো what is the vibrational degree of freedom. খেয়াল রাখো, just look at the picture again. If this is a system where we can see oxygen, hydrogen, and again here one hydrogen. In chemical bonding, vibration always happens due to the attraction and repulsion between molecules of an atom. Here water molecule, the molecule is water molecule. How a molecule is formed? It is the aggregate of atoms. What are the atoms? Hydrogen 1, 2 and oxygen 1. So whenever we have different atoms, we have attraction, that means attractive force or repulsive force, মানে আকর্ষণ বা বিকর্ষণ বল কিন্তু এখানে থাকবে, and for that these particles just vibrate, just moves some to some extent forward and to some extent backward. This movement is so small that we cannot just even realize often, but in chemical bonding the subject spectrography, this is the subject which is very much a graphical representation of all this, and this shows us that vibration is possible. So vibrational degree of freedom, though easy to calculate by this particular formula 3n minus 6, it is not at all easy to just describe as we have described translational or rotational motion. Vibration just happens by keeping this one fixed and between these two, also between these two. So vibration along this axis and this axis are possible. Clear? But the beauty of this atom was, just we see these 3 points H, O and H, these are non-collinear. একই সরলরেখায় তো নেই. These are non-collinear points. So when we have some molecule where non-collinear structure is there, the formula to calculate degree of freedom is always 3n minus 6 for non-collinear molecules. Clear? We will see. This is the benzene ring. We all know that this is like C6H6, this benzene ring. And for benzene ring, how many molecules are there? One molecule. Here we have taken one molecule of benzene ring. And how many atoms? Say 6 atom C carbon and 6 atom for hydrogen. So total 12 atoms. Is this non-collinear? That means, can we just here see all the points, all these 12 points, 12 atoms means 12 points, can we see them in a particular straight line? No. Since they are not along a straight line, so they will be called non-collinear. And we have already seen that DOF for non-collinear, vibrational DOF, obviously vibrational DOF equal to 3n minus 6. That means 3 into how many atoms are there? 12. So minus 6, that means 30. So the answer for benzene in case of degree of freedom, obviously vibrational will be 30. Next we come to the most interesting part, that means collinear atom. These two are collinear atoms. I am giving you clue about this. Very similar treatment will apply for this also. Carbon dioxide, that is collinear. See what is the beauty. If we just place carbon dioxide molecule by fixing carbon here and one oxygen here and one oxygen here, then this is collinear atom. What is the beauty of collinear atom when we discuss vibrational degree of freedom? See what happens. Again, as before, we can move it along x-axis, y-axis and z-axis. So 3n equal to translational degree of freedom ft will be clearly 3, plus last one is vibrational degree of freedom fv. We are like to just calculate this. আমরা এটাকে ক্যালকুলেট করতে চাইবো. So translation, we have easily arrived at the fact that translation is possible. As before, in case of H2O, we have seen how translation is possible. Now comes the beauty of rotation. See, since this carbon dioxide molecule is taken along y-axis, so its rotation is only possible along z-axis and x-axis. This is our y-axis, this is z, this is x. Why? Because see, this is a particular axis, say z. Just keep a close look about this fact. This is very important. Often students feel difficulty to understand this. I hope after this video you will all understand. Just keep a close look at this particular topic. Whenever this y-axis, this is the y-axis, so it is its initial position, this position. Now we can rotate about z-axis, and this rotation, say one man is standing 300 meter away from the place where this is happening. That means we have a rod in a park and another rod, this rod is AB and another rod is CD. So CD is just swinging about this, and a man standing 300 meter away from this position can easily see that a rod is swinging about another fixed rod. This motion is visible clearly about 300 meter or a far distance also. Similarly, this rod CD can make it rotation about x-axis also. So two type of rotations about z and x-axis are obvious, but the problem comes when it rotate about y-axis, and a man standing at 300 meter can easily see that motion. The answer is no. Why? Just we will see why. This is the logic. All of you must take a look at carefully. This is y-axis. Now our question is whether rotation about y-axis, that means about its own axis, is possible. Yes, it is possible, because it can rotate like this. Just if you take a pen in your hand and just, this is the pen, say, and we often in our leisure time just rotate it about like this. But the question is, can a man, say at 300 meter away from this position, can he realize that type of motion, that type of rotation? No. So this is the beauty. This type of rotation will be invisible. That will not be any significant part of chemical bonding. So for that, this rotation about its own axis, y axis, is not taken into consideration. So we have here translational degree of freedom 3 and here 2. What is that degree of freedom? Freedom due to rotation, that is 2. So the ultimate formula for FV, that means freedom due to vibrational, will be 3n minus 3 plus 2, that means 5, অর্থাৎ 3n minus 5 হয়ে দাঁড়াবে। কার জন্য এটা কি বললাম? কোলিনিয়ার অ্যাটমের জন্য for DOF from now on will be determined by this formula 3n minus 5. So for carbon dioxide, what will be like this? Carbon dioxide, how many molecules are there? 1, 2, 3. So here 3 into 3 minus 5, that means 9 minus 5, that means 4 will be the result. What is for carbon monoxide? This is your homework. I hope all of you can do it. Just put it in this formula. But what is the beauty? The beauty lies in the fact that these two type of formula, one is 3n minus 5 and one is 3n minus 6. These two, this is for collinear, this is for non-collinear. We should not just memorize these results. If we have any difficulty in understanding, then to remember a result will be difficult. So we have just seen what is the detailed discussion of degree of freedom. And now we will come finally in today's lecture about a CSIR question on this particular topic. I hope before I can discuss this question, you can answer it, say, in 5 seconds. So just pause the video and try it. The answer will be very simple. What they have asked. This question was set in CSIR December 2012. Single choice question of 3 mark. Very easy 3 mark. But for math background students it is difficult. So we have to learn everything in details, and I hope this video will help all of you to understand. If you feel any difficulty at any stage, please ask in our comment box. The total number of vibrational degree of freedom. So say what they have asked. They have asked about FV. What is FV? We have two formula. One is 3n minus 6, another is 3n minus 5. What will be used here? That is the clue. Collinear atom, and we have already seen that for collinear atom it is always 3n minus 5. Here the detailed discussion has been done on CO2 and CO. So the result will be clearly, now you can all, I hope all of you can see this is the answer. This should not be the answer. This was the answer. This answer have been true if they have asked about collinear, non-collinear atom. For non-collinear atom it is 3n minus 6, it is true, but for collinear atom it is always 3n minus 5. So we hope all of you have understood today's lecture. If you feel any difficulty, please like, please comment, and just share, like and subscribe if you feel interested in these lectures. So until we meet with more questions on this topic, that means degree of freedom, DOF, from competitive exam, it is goodbye from our team.